So this is a very short 15-minute spotlight on our unicorn portfolio, AI hardware and inference company Groq. And we have with us Igor, head of hardware at Groq. So I know that everyone wants to ask questions of you, so I'll keep myself short, and then we can go into 5 minutes of QA. Please introduce yourself and your role at Groq.
Okay, Igor Arsovski, I'm the chief architect and the head of hardware at Groq. I've been with Groq for 2.5 years. Before that, I was at Google, working on optimizing the next generation TPUs. These are the accelerators that Google uses. And before that, I was the CTO of the Marvell ASIC business unit.
Tell us about Groq and what makes it so special. We have a combination of portfolio companies and TDK folks who are in the DX, who would obviously know very well about Groq, and then we also have folks from the EX. So tell us about Groq, what makes it special, how is it different from, say, a GPU or a CPU?
Yeah, so Groq has been an 8-year in the making overnight success. We have started in 2016. The company was started by Jonathan Ross. He was the initial inventor of the TPU at Google. He spun out Groq at that point and developed a unique processor that is both an accelerator and router in one. And what's unique about it is that it is really good at processing sequential operations with very low latency. So CPUs are really good at sequential operations, but they can actually process one thing at a time. GPUs that were introduced about 20 years ago can do a lot of parallel operations, but they can't do sequential operations really fast. Groq's language processor unit, or LPU, can actually do both of these things really fast. So we have very low latency, and that's also allow us to do very low power and high performance type processing as well. So it's a unique custom silicon.
Could you also speak to the vision where you want to make compute available at very low cost to everybody?
Yeah, I mean, Groq's mission has been to drive compute, the cost of compute to zero. I don't know if we're gonna quite get there, but we wanna push really hard on that, and we wanna democratize the access to LLMs. We don't train the large language models that we use. We use open source models like Llama from Meta and others. But what we do is we build hardware fully vertically integrated from the silicon, the system, all the way to the cloud that you guys can all try out if you go to groq.com. We basically offer that whole stack that makes these large language models run really fast and very power efficient. We can get efficiencies that are on the order of 3 to 5x better than current GPUs. And we can get speeds that are really best of breed in the industry at this point. Yeah.
And the comments from you about tokens per second, latency, multimodality.
Yeah, so Groq has been on a really quick ramp. We have gone from 0 to about 500,000 developers in about 6 months. So this is probably the fastest hardware adoption of any platform that I've seen. We offer multimodal model support. We offer all the models that are basically available from Meta and Mistral and other companies that open source their models. We offer API access to anybody that's interested, so you can actually get access to Groq and start developing on it. Yeah, it's been a really exciting ride over the last year. Yeah.
Thank you. So we knew that Groq has over 50 TDK components designed in its current board. But let's talk about the future of your products. Power is a very important and critical issue for AI chips. Groq recently had a brainstorming discussion with TDK's IC collaboration group, and you were in that discussion along with your CTO, Dinesh. Groq also has been working with Faraday Semi, Parvez's group, with the mu poles So without divulging anything confidential, what can you tell us about your component needs and your power needs and market trends in power? We have many TDK team members from sales, from business groups, and our corporate officers who would very much like to know.
Yeah, power is kind of quickly coming up to be the number one issue in deploying AI. Currently, there's a hunt for any available power across the world. So a lot of companies are trying to secure that so they can actually deploy more compute. Obviously, low power solutions are really needed to optimize this, to maximize the amount of compute that you can deliver within a single specific power envelope. At Groq, we have a very unique approach to doing the compute. If you look at a specific GPU, you typically process the data by constantly paging data in and out of HBMs. These are really good storage devices that are really fast bandwidth to memory, but every time you page that data, you burn about 4 picojoules per bit. Groq has taken a unique approach. As opposed to moving the weights back and forth from HBM, we've kept it all on the chip. We've increased the number of chips, so we only move activations from chip to chip. By doing this, we have actually reduced power anywhere by 3 to 10x, depending on the models that we're using. So this is almost an order of magnitude better power behavior per token. So for every token generated, we can actually consume 3 to 10x less joules of energy to do this. Having said that, we're going to try to push the envelope and try to get more compute in a unit area. So we're going to be adding more and more compute, which is going to drive more power requirements. From the vertical power regulation side, this is really a push to get better efficiency out of that, less resistive drops. So we want to get that. We want to reduce the DIDT component of it. And just to give you a feel, if you took like a GPU deployment of, let's say, 100,000 GPUs right now, you would be burning about enough power that will cost you about $150 million a year to kind of just run that. If you shave off 50 millivolts in your voltage drop because you have better LDIDT, better resistive drops, and so on, that's equivalent to about $25 million worth of energy savings. So 50 millivolts, lower voltage, like $25 million in savings. And then if we kind of look at the vision that TDK put out on sustainability, that's about 200 million pounds of carbon shaved just by reducing that voltage by 50 millivolts. So any push in that direction is absolutely something that we are really careful about leveraging. Yeah.
And as you are going towards those low voltages and conservation of power, any current strategies on thermal cooling the team would like to know?
Yeah, I think we're still staying as air cooled. We are burning significantly lower power than GPUs, so we can afford to continue to be air cooled. But as we move to the next generation systems, I think these are going to be driving both higher current densities. At the same time, they'll be driving also cold plate cooling and kind of beyond that as well. So those are definitely things. We're currently still using a lot of TDK components, even in our current system, our next gen system. We find them very competitive, up to 20 amps. I think we've seen a lot of the regulators are really competitive, and they're kind of also being used on our bring up boards for our next generation silicon.
So that transitions us to the next gen. So talking of roadmap, you were on the old node since 2019 and still outperforming everyone. It's just blazing fast. I've used it. What can we expect next year with your 4 nanometer node?
Faster and lower power. The amazing thing about Groq is that we have been outperforming the competition with 14 nanometer silicon. This is silicon that was taped out in 2018. So it's really, Groq is an architecture play. That's how we're getting the significant performance benefits. 4 nanometer, I'm not going to divulge too much information on it, but it is definitely pushing significantly better performance. If you just look at 14 to 4 nanometer, just like brute force scaling, it's about 3x lower power, just with brute force scaling, not ignoring any architectural improvements and everything else that we have already incorporated into the silicon. That silicon is taping out this month. So my team is working around the clock, so I'm going to be taking off after this as well. So
thank you so much for making time for us.
Absolutely.
Final question is, we have so many startups here. You heard our CTO mention that TDK itself started as a startup. So startup is really not for the faint-hearted. What would you like to share with our audience on engaging with larger corporations like TDK? Any useful tips that you can give our entrepreneurs here, as well as our team members in the audience?
Yeah, first of all, I want to appreciate kind of the support that we've gotten from TDK, both from the funding us. Also, we've gotten tremendous support on kind of on the application side. On the advice side, I think as a startup, you need to really differentiate by not by 10%, 20%. You need to be multiple X in order to be seen. And then engaging with larger companies. As a startup, we really depend on the companies to be our partner. We don't have the resources to develop into big solutions internally. So we're going to really leverage kind of that engagement to kind of get full support and kind of partnerships where we don't add as much value add. We kind of lean on our partners to get that from them. And TDK has done a great job on that side.
I think that was my final question, but before we move for the next 5 to 7 minutes to audience question, wanted to know your thoughts about the 2024 Nobel Prize in Physics for AI compute.
Yes, this is Jeff Hinton?
Hinton and Hopfield, yes.
Yeah, so Jeff Hinton was a professor of mine at University of Toronto. I think it's pretty amazing how quickly this has moved. I can imagine if you just look at the curve of papers, AI papers released, you can see a strong exponential kind of growth. And I think Jeff Hinton started this with a handful of students. All of them kind of expanded into being a chief technologist at OpenAI, starting up new startups right now. So it's been an incredible kind of trust that Jeff has had to keep pushing in this direction that have had a lot of false starts and failures. They call them the winters and summers of AI. So I'm super excited to kind of hear the field starting to get recognized. Yeah.
Thank you, Igor. I'm sure there's a lot of interest from our audience to ask questions. We can open it up.
Great. So my question is, what's the challenge that Groq sees getting traction with some of the bigger players, data centers in the space like Microsoft, Meta, and Google and such, for their mass, and even OpenAI for their large deployments?
Would you introduce yourself, Vishal?
Yeah, I'm founder, CEO of Analog Inference. We are also doing AI accelerators.
Excellent. Yeah, I think Groq has kind of reached that tipping point. So by the end of this year, we'll have over 100,000 of our LPUs deployed. We're looking to 10x that next year, just with that one client, and grow that beyond that. So I think we've kind of hit that point, 500,000 developers. The big challenges always are, how do you stand up a cloud as a team? How do you offer that whole vertical stack as opposed to trying to offer just a hardware device that then needs software to work well with it. And this is the biggest challenge I've seen with a lot of AI startups. They provide a hardware device. They say this hardware device is capable of so many TOPS and so many TOPS per watt. But there's a saying in the industry that if you build hardware and there's no software for that, does the hardware really exist? It's kind of like the psychological, the experiment of if a tree falls in the wood and nobody's there to hear it, it doesn't really make a sound. So I think that's the biggest challenge I find for AI startups is providing that full vertical stack, and that takes a lot of effort. Groq alone has gone through 3 separate software teams to get to the point that we are right now. So it's been a heavy lift, but at this point where we can really turn around large language models within 10 hours. So Llama 3 was released within 10 hours. We had it running on our cloud, developers developing it. So, but that's a big lift, I think, for a lot of AI startups. Yeah, go ahead.
When I proposed to invest in Groq, one of my key reasons was we cannot guess the upper limit of the inference market.
Yes.
We just can't. It's like unlimited. Can you give us a sense of, by end of next year, what do you think will be the market share you take on that huge inference market?
Yeah, so I think we're still at the tipping point. I think even Jensen Huang last year said that inference is starting to like pick up, and he was seeing 40% of the GPU usage for inference. I think we're expecting that balance to tip very heavily in inference side to become 95% potentially. Training will still be big. GPUs will still do well in training, but Groq has made a conscious effort to not compete on the training side, to focus on the inference side, because this is the growing piece of the pie, and that's where we're focusing on. The demand is tremendous. At this point, the biggest challenge we have out of those 500,000 developers that we have on our cloud is not how can we lower the price, it's can we buy more tokens per second at this point? And we are struggling to deploy as much hardware to kind of support that part. Yeah, so that's the biggest ramp right now. We've been doubling our number of racks every month effectively. So that's the big push.
So it will be a big pie, but how much of the pie do you think you can get?
I don't know. I don't know. Even if we get a tiny piece of the pie, it would be a huge business for Groq, but we're pretty ambitious about it. And we're just starting, as I mentioned, right? 14 nanometer silicon, first generation system is the one that's like achieving these amazing performance results. So much to optimize with our second generation system, so much to optimize with our second generation silicon. We haven't even scratched the surface of complex MCMs. It's still a single chip module that we're using. So there's a lot of technology potential behind it. But we're not going to sit just on the technology alone. We're going to keep iterating on the architecture as well. Yeah, so a lot of potential.
Yes, go ahead.
Do you think that the existing power solution today that you use for multi-phase or anything else, they are good enough, or you think in general, including Groq technology, they require a different type of power solution?
Yeah, so Groq is unique in, this is like a superpower that made me jump from Google to Groq, is the fact that the design is deterministic, 100% deterministic. What that means is that down to every nanosecond, we know exactly how much power is consumed at every X, Y, Z location. And not only like we know it ahead of time. During compile time, we know how the power is going to be burned. So this gives some unique opportunities, both on power delivery, thermal solutions, 3D stacking, which are all out of the hands of GPUs, in my opinion, because the non-determinism doesn't allow you to be proactive. You can only react to the problem. Once thermals are exceeded, you throttle the GPU. Once power is exceeded, you have to throttle your performance. We can actually account for that right up front and kind of build on it. So this is the superpower that might be really kind of...
That's what I'm referring to. So
yeah.
As you know, that like an Intel CPU has some kind of communication interaction with the actual power.
Yes.
But with the AI chipset inherently, you can actually build that AI into the entire system, including the power, in order to really prepare for the transient event and many other important tasks that you really, as you said, lowering the voltage, save a lot of electricity costs, and overall improving overall delivering the efficiency and the power together. That's right.
Yeah. So we're going to release some interesting announcement on that pretty soon. But yes, exactly. Yeah.
Thank you so much, Igor.
Thank you.
It's a
Thank
pleasure
you.
having you.